In this video, we solve problem 8.3.012.mi from the Larson and Edwards Calculus Early Transcendental Functions text, 7th edition. We're asked to find the indefinite integral and use c for the constant of integration. And we have this integral right here. Well, if we look at our guidelines for integrals involving the powers of sine and cosine, we see that if the powers of sine and cosine in our problem are all even and non-negative, and they are, we don't have any cosines. Obviously, a 4 is a positive even number. Then we are instructed to use our power reducing formulas, because our power reducing formulas will allow us to write this integrand in terms of other functions that we have basic rules for. So according to the guidelines, we're going to use the power reducing formula for sine of 5 theta. Now the power reducing formula for sine is this. It turns out that sine squared of some angle is 1/2 of 1 minus cosine of double that angle. So here I've got a sine to the 4th, which is a sine squared times a sine squared. Of course, the angles are the same. So I would start by rewriting that as a product of a sine squared and a sine squared function. And then each of these can be rewritten using this power reducing formula. So we're writing each sine squared function in terms of cosine using the power reducing formula. So according to this first sine squared of 5 theta is 1/2 times 1 minus cosine of 2 times that angle, and this one is the same. Now in this case, our angle is 5 theta. So this formula says that we're supposed to double the angle. So I'm going to go from 5 theta to 10 theta. And then remember, multiplication is commutative, so we can factor out this 1/2 times 1/2. 1/2 times 1/2 is 1/4. We can bring that outside. And then we can FOIL. We can take this 1 minus cosine function and multiply it by this 1 minus cosine, and just do first times first, plus outer times outer, plus inner times inner, plus last times last. And that's going to give us a trinomial. So first times first in this case is 1. Outer times outer is negative cosine of 10 theta. Inner times inner is another negative 10 cosine, or is another negative cosine of 10 theta. So we have 2 of those. And then last times last is a cosine squared of 10 theta. Then we look at this and we ask ourselves, do we have a rule for that? And we have a rule for that, and we have a rule for that, but we don't have a rule for that. But that is an even power of cosine. Since the power of cosine is even and positive, we're going to use the power reducing formula for cosine. Now the power reducing formula for cosine looks a lot like the power reducing formula for sine. The only difference is that instead of having a minus there, we're going to have a plus sign there. So this turns out to be 1/2 of 1 plus cosine of 2 times the angle. The angle is 10 theta, so doubling the angle would give us 20 theta. And that's the same thing that we did here, except over here we were taking this sine function and replacing it with this. And then here we're taking this sine function and replacing it with that. We're just substituting. Okay, so we're taking this and we're going to replace it with that, but it would be helpful if we distributed. So this will be 1/2 times 1, which is 1/2, and we have 1/2 times this cosine function over here. It's 20 theta. All right, and then we can simplify all of this. We have 1/2, or 1 plus 1/2 here. That's 1.5, or 3/2. And then we have a minus 2 times cosine of 10 theta. And then a plus 1/2 cosine of 20 theta. So remember, what we're doing is we're using this power reducing formula to write it like this. And our hopes are that after writing it like this, we'll be able to integrate using our basic rules or anti-differentiate using our basic rules. We can't quite do that yet. So we simplify. We've got something that's similar to a binomial. It looks like a binomial times a binomial. So we distribute, we get that. We say we've got a rule for that and a rule for that, but we don't have a rule for that. So we use a power reducing formula again. And then we simplify, and then we look at all of our terms and we say, do we have rules for all of these? Well, I have a rule for that, and a rule for that, and a rule for that. So yes, this is going to work out just fine. I would also probably distribute the 1/4 at this point. So we've got a 1/4 times 3/2 is 3/8. The antiderivative of, well, actually, let's just distribute first. -2 times the 1/4 is going to be -2/4, or -1/2. And the 1/4 times the positive 1/2, just multiply straight across, gives you 1/8. And we're here. Okay, now we'll just use our basic rules for each of these terms. The antiderivative of a constant is your constant times the variable. In this case, the variable is theta. Then we'll bring the -1/2 down, and then we ask ourselves, well, what's the antiderivative of cosine? The antiderivative of cosine is sine, but if you have a constant times your variable inside, remember, if you were to take the derivative of sine of 10 theta, you'd get derivative of the outside, which is cosine of 10 theta, times the derivative of the inside. So you'd have to multiply by 10. When we're anti-differentiating, we have to divide by 10. So that's that kx modification that we've talked about. If you have a constant times your variable inside, you just apply the basic rule. You replace the variable with your constant times your variable, and just make sure you divide by that constant. So if that's a kx, we have to have a 1 over k out front. So we have that there. Same thing here, you've got a 1/8. The antiderivative of cosine of an angle is sine of that angle. Since you've got a constant multiplying that variable, we need to divide by that constant. It's just like undoing that chain rule. We'd multiply by 10 when we differentiate, multiply by 20 when we differentiate. So to undo that, to anti-differentiate, we'll divide by 10 or divide by 20. And we get that. And of course, we want to simplify where we can. (20 theta). And that's our answer. So your goal is really just to use power reducing formulas or whatever formulas are appropriate for each of the terms until you get to a point where your basic rules apply, and then you just anti-differentiate and simplify.